For our first experiment, we're going to do separation of the components of a given mixture. Okay? The objectives of this experiment is first to learn how to separate different substances in the mixtures based on their different physical properties. In addition to that, you should also learn about the different methods of separation such as decantation, extraction, filtration, centrifugation, and sublimation. Mixture. In the classification of matters, we can classify mixture as one that's made up of two or more substances that do not react chemically, and they can be separated by physical means. So in a given mixture, each of the component substances retains its identity and its physical property. And if one of the component is present in by far the largest amount, we can call this mixture as what we call impure substances. Okay, so when one of them is just present in largest amount, we have an impure substances, and the one that is present in a smaller amount, that is what we call impurity. Okay, now you may ask yourself, why do we need to separate mixtures? Okay, why do we need to separate them? Now, for instance, let's say when we're dealing with what we have in our everyday life, drinking water, they usually contain other materials. Okay, they said water, if we're going to look at it, it's a mixture of silt, sand, salts, and water. Now, we want our drinking water to be pure. So in doing that, we want to remove all impurities that it has. Okay? Now, if you're going to look at the components of the mixtures, there are either elements or compound. And we can identify each of these elements and compound that are in the mixture. So what we're going to do today is we have a mixture made up of two substances, and we're going to separate them. Okay, now let's look at the technique that is being used to separate mixture based on their physical properties. So the first thing that we have is distillation. So when we're doing distillation, we purify liquid by heating it to its boiling point, condensing its vapor and collecting the condensed vapor. So in this case, we could say the separation is based on the difference of the boiling point. Okay, so for instance, if you have an alcoholic drinks, it's a mixture of alcohol and water, so you separate them based on the difference of ethanol, which is the alcohol component, and water. Now, the next technique that we could use is extraction. So extraction is the removal of one substance from a mixture because of its greater solubility in a given solvent. So we could say this is based on solubility. And you're going to do this in this experiment. You have a mixture that contains a water soluble and a water insoluble component. So when you put them in water, the one that remains undissolved, that's the water insoluble. The one that dissolves is water soluble. Now once you do that, okay, you can separate them using the next technique. Okay, so in filtration, what you do, this is the process of removing an insoluble component from a liquid mixture with the use of a filtering media. So usually you have a funnel here with a filter paper. Okay, you're not going to use this what we call technique. And then you can also use centrifugation, the process of separating a suspended solid from a liquid by whirling the mixture at high speed. So you need an equipment here that's known as centrifuge. You're taking advantage of the centrifugal force, okay? And what do? It force your solid component to settle at the bottom. Now what you're going to do to separate your water soluble and water insoluble in this experiment is decantation. So this is just very careful pouring of the liquid component of a mixture to achieve separation from the settled solid. Okay, so you just allow them in time to settle down, and then you pour them. You remove the liquid component, leaving the solid component on it. Now the last technique that you can use is sublimation, and we're not going to do this before. When this is a 3 components experiment, this is the first thing that we do. So sublimation is just the process wherein you have a solid and it is converted to the gas phase without passing the liquid phase. So usually you apply heat here. Okay, so this is applicable for substances that sublimes. So example of those that sublimes, you have the iodine, CO2. And we're not going to do this experiment. We're not going to use this what we call technique. So the mixture that we have is SiO2 and what's the other one? NaCl. So what's the main difference between the two? Okay, their solubility. So the method of this experiment is very simple. Since this is the first experiment in the class, so we do it little by little. So what you're going to do is you're going to weigh an evaporating dish. Once you weigh the evaporating dish, you're going to add the unknown sample that contains silicon dioxide and sodium chloride. So when you say silicon dioxide, that's just the sand. Okay? So you add it to the evaporating dish and then you weigh it. And weighing by difference, you get the mass of the sand and salt mixture. And then what you're going to do, you add 30 ml of water to your sample in the evaporating dish. You stir it gently for 5 minutes and then you decant. So what's happening when you stir it gently? That's where extractions come in. And once you extract it, what does it extract? It extracts the water-soluble component, which is your salt. Okay? So how do you separate them? You decant it. So when you decant, you separate the liquid component from the solid component. And then after you decant, you collect the liquid. So what is left there in the evaporating dish is the solid. You add more 10 ml of water. And then you stir it gently for 5 minutes and then you decant. And then you add another 10 ml of water. Okay? And then you stir it gently for 5 minutes and then you decant. So overall you add what? 50 ml of water. So once you do that, the one that is left now is the sand that still have traces of water in it. So you're going to heat the evaporating dish with the sample. It's just removing the water that you have, and then you allow it to be cool, and then you weigh it. How do you know it's cool already? You can touch it. Okay? Now, while you are what we call heating this evaporating dish, you're going to get another evaporating dish. You weigh it, and there you're going to put the collected liquid sample. The one that you decant, and then you're going to heat to evaporate the liquid. So you're removing the water. So once you do that, what will happen is you're going to collect the solid. Okay, and you have to be careful because by the end it will start to sputter. So what is what we call sputtering? some of the solid component will just what we call loss in the process, because when water is being removed, you're also heating here the solid component that is being collected. So the idea that we have here is you turn off the heat until all the water is gone, to prevent sputtering, because if you have sputtering, you're going to lose some of the solid component, will give you an erroneous measurement. You cool it, and then you weigh the evaporating dish with the solid. So once, okay, you have what we call the solids collected, you're going to calculate the data that you have. Now, once you have collected the data, you may have an entries like this. Now, this set of data, I will provide this to you. Now, in some cases wherein you see some blank in the data, that means you have to put that blank. Failure to do so would means deduction in your lab report. So for instance, here, you say here the weight of the sample. So how are you going to determine the weight of the sample here? So weighing by difference, all you need to do is 55.64 minus 49.56. So this is equals to what? So if we follow this one, this is around 6.08. Okay. This one, 52.32 minus 49.56. So this is equals to 2.76. And then 53.35 minus 50.43. So this is equals to 2.92. So it's your responsibility to provide the blank data, and usually it's just mathematical operations of the data that was already provided to you. Now, in this experiment, you are required to determine the percentage of SiO2 and the percentage of NaCl. So how are you going to do that? Based on the data that you have, you can determine the percentage of SiO2. So based on the data, that's 2.76, the mass of the sun that you have, over 6.08. That's the mass of your unknown sample. So you multiply it 100, you're going to get around 45.39. Now for the NaCl, you do the same thing. So the amount of the NaCl that you were able to determine is 2.92 grams divided by 6.08 times 100, you have around 48.02. Okay, so what you're going to do, you're going to add the two of them together, 48.02 plus 45.39. So you only have here what? The total for them, 93.41. In theory, you should have what? 100%. So you could say there must be some erroneous error on it. I've told you I'm going to provide you a raw data. It may be part of the recording or a document that contains the data. And you're also required to answer the questions at the end of each experiment. So this is how experiment 1 goes.